too, right?
I'm PowerPointless today. So my research group does life cycle assessment, which is an environmental, social, and economic accounting framework to help us reach the third of the three U of A pillars, right? A resilient future. So you manage what you measure, and one of the tools for measuring sustainability and quantifying sustainability is life cycle assessment. Our work specifically focuses on food systems and agriculture, and for me it's incredibly important because we have somewhere between 2 to 3 billion people coming to dinner in the next 30 years, and agriculture currently occupies, pardon me, something like 70% of the arable surface of the planet. It's the single largest footprint of humanity on the planet, and so understanding how we operate our agricultural systems is critical to, well, frankly, geopolitical stability. I'll say something that my brother finds horribly offensive. The planet, folks, is in not very much danger, okay? It's us who are in grave danger from the way that we produce and consume our goods. And so understanding the way in which we do that and trying to identify ways to do it better is really important. So life cycle assessment is a triple bottom line accounting tool. It has a framework that starts with setting the goal and the scope for a particular project, collecting inventory data, and we've talked a lot about data. Life cycle assessment is a data-hungry science, right? So we try to figure out, to calculate, for example, the carbon footprint of a gallon of milk. You have to know how much electricity is used and where was it produced and how the coal was mined and all of the stuff, all the way through to the disposal of the plastic packaging and the emissions that might have come from the landfill. So it's a model of at least a slice of the entire economy. So it's complicated, complex, and there's a lot of information that's necessary to do it. The next step is the impact assessment. And so if I run a life cycle assessment, I'll have probably a list of 10,000 emissions from the supply chain. How am I going to tell anybody what decision they should make, when there's 10,000 variables that you have to juggle? So the life cycle impact assessment stage is built upon all kinds of science. Epidemiology is one of the big ones, but also physical sciences, understanding the role of nutrients in the environment, et cetera, et cetera. And so we collapse this large number of emissions into somewhere between 5 and 18 impact categories that we think will enable us to make more intelligent decisions or understand the impact that these systems are having on the planet, and therefore on our ability to continue producing food at the levels that we have, so that we don't have hangry people knocking at the door. And then, of course, you have to interpret it, right? What does it mean, and what are the decisions that we might support? How do we move forward to make our production and consumption systems more sustainable? So life cycle assessment evolved from industrial ecology, which is really focused on plants. The very first life cycle assessment, interestingly, was done in the mid-'60s. Coca-Cola wanted to know whether they should jettison the glass bottles and go to plastic. And we know what the result of that study must have been, don't we? So, because of that, because of its origins, it is really integrative across space and time. Right? So we've been talking about geospatially distributed processes and temporally distributed processes. Life cycle assessment grew out of really a battery limits industrial paradigm. And so space and time weren't really very important, but as it began to be used in agriculture, space and time become more and more and more important. Obviously, for greenhouse gases, right, for carbon emissions, the carbon footprint of a good or a product, it really isn't critical when or where the greenhouse gas was emitted, because in a matter of months or years at most, the atmosphere is well mixed and the radiative forcing occurs at global scale. There are a few things like soot from the freighters that are now going through the Northwest Passage and changing the albedo of the snow that are local and do matter. But for agriculture, it's critical that we understand the spatial and temporal influences of the things that we're doing on the landscape. And so one of the things that my group, and we've talked with Jack a number of times, but we've sort of had fits and starts getting going, is to come up with a paradigm for coupling the geospatial data that we have with the life cycle impact assessment, because we need not only geospatially and temporally explicit inventories, right? Where was this resource extracted, or where was this operation on the planet? What were the emissions from the wastewater? Where did they go? All of that has to be trapped and captured. In addition, the impact of withdrawing a cubic meter of water in central Arkansas is nothing like the impact of withdrawing a cubic meter of water in New Mexico or Arizona. And so there are not only spatially and temporally important aspects of the inventory, there are spatially and temporally important aspects of the impact assessment. And so I would invite you to talk to me about how can we do this better, because the life cycle assessment, I think Marty, before he left, hinted that, or at least in a side conversation, he said the LCA folks, they don't have a clue about how to do this. They're trying to, drives me crazy, guys. The LCA community is trying to jam a GIS into a matrix inversion software tool. And it's just nuts. It's just nuts. What we need to be able to do is we need to be able to make the life cycle assessment tool and add on to the GIS tool. And if we could do that, then we would have a major step forward. Okay, so I've got one more thing to talk about, which is the way in which my group is thinking about convergence and convergent research. And I'll use an example of a proposal that we recently submitted to USDA. So I was the guy that forgot to step back when they called for volunteers, and so yes, I forgot to step back, and so I got to lead this. I got to herd the cats, as it were. So our idea is the dietary guidelines recommend that collectively we should be eating more fruits and nuts, vegetables, fish, and dairy. And so we asked the question, how can we do this in a manner that will be supportive of producers so that they can retain profitability, and at the same time provide affordable, high-quality nutrition to nutrition-challenged low-income populations. And so we put together a team that's got an agricultural economist, it's got epidemiologists, it's got sociologists, it's got people from education, it's got a health physicist, it's got a manure specialist from University of Wisconsin, and we've got people who are electrochemical specialists who are going to work on aquaculture production to bring that all together. And then layered on top of that is, in the LCA paradigm that one of my colleagues has been developing, is an inclusion of the effect of diet on human health, right? So in traditional life cycle assessment, we would talk about, well, all of these carcinogens are released. We've got pesticides in the environment that farm workers are exposed to, and so there's human health impacts. But we never talk about what are the beneficial and detrimental, potentially, effects on our collective health of what we eat. I mean, it's huge, right? And very important. And so we're rolling all of that stuff together, and it's, well, it seems like a pretty convergent project. And if any of you happen to be on the review panel, I didn't say that. Anyway, so the last thing I'll say is that life cycle assessment is an integrative platform for communicating the impacts of complex systems, and it's not easy. It's not any easier than any of the other things that we've talked about today, but it does provide a framework for pulling a lot of really complicated things together into a manner that can hopefully be communicated to people who want to make decisions. And so I'll stop there. Thanks.